Multiplicity. Multiplicity, the definition, if a factor x minus c occurs k times in a complete factorization of a polynomial, then c is called a root of the polynomial when the polynomial equals 0 with a multiplicity of k. So multiplicity counts how many times that root appears. So if this is my polynomial, hopefully you recognize this as the x plus 3, the quantity squared. So the root x would equal negative 3. So we would say that negative 3 has a multiplicity of 2. It appears 2 times. Now, if p of x equals 0 is a polynomial equation with real or complex coefficients and a positive degree n, then when a multiplicity is considered, p of x equals 0 has n roots. So it has as many roots as the degree of the polynomial. But sometimes one of those roots may appear more than once. So we need to find all the zeros. Well, this is already in factored form. Here, x minus 2/3. So x would equal 2/3. And that has a multiplicity of 2. X plus 1 equals I, so that would be x equals, and here's a minus 1, so plus or minus I, and here x would equal 3, and because of this cubed, it has a multiplicity of 3. So that's 2, 3, 4, 5, 6, 7 roots for that polynomial. We're going to find all the zeros of this polynomial. They're going to tell us that 3 is 1 0. So since this is a cube, I can go ahead and factor. 3 is a 0, so I've got 3, 1, negative 2, negative 5, and 6. 1, 3, 1, 3, negative 2, negative 6, and I have a 0. And then I have x plus x squared plus x minus 2, which would factor into x plus 2 times x minus 1. X equals negative 2, and x equals 1. So my factors are 1, negative 2, and 3. Let's do that same thing. This time our negative 3 is a factor, so negative 3, 1, 5, 8, 6, 1, negative 3, 2, negative 6, 2, negative 6, and that's 0. So x squared plus 2x plus 2. That does not factor, so we have to use the quadratic formula. So x equals negative 2 plus or minus the square root of b squared minus 4ac, so minus 4 times 1 times 2, minus 8 over 2a, 2. So x equals negative 2 plus or minus the square root of negative 4 over 2. That leads to negative 2 plus or minus 2I over 2, or negative 1 plus or minus I. So all the zeros of this polynomial would be negative 3 and negative 1 plus or minus I. Now, you might have noticed on those last two that we had a plus or minus I, and then we had a negative 1 plus or minus I. If p of x 0 is a polynomial equation with real coefficients, now, it does specify we have to have real coefficients, no complex ones, and if the complex number a plus bi, where b is not 0, so it has an I part, is a root, then automatically a minus bi is also a root. They always come. You might recognize these as conjugates, a plus bi and a minus bi. This is the conjugate pairs theorem. It says when one complex number is a root, then its conjugate is also a root when you have real coefficients. So find a polynomial of least degree that has only real coefficients, and it has zeros, -4, and 3 minus I. Oh, 3 minus I is a coefficient. We also automatically know that its conjugate, 3 plus I, is a 0. To find this, they're giving us the factors. We have to find the polynomials. So we know that factors of the polynomial would be x minus -4 times x minus 3 minus I times x minus 3 plus I. Do remember to put those 3 minus I and 3 plus I in parentheses, an extra parentheses, so we're subtracting the whole thing. I'm going to multiply the complex terms first. So x times x is x squared. X times the 3 plus I will give me, so I have x times 3 plus I. Oops, it's a negative. It's a negative x times 3 plus I. And the middle terms will give me a negative x times 3 minus I. And 3 minus I times 3 plus I is 9 plus I squared, 9 minus, sorry, I squared. Removing those parentheses. X squared minus 3x minus xi minus 3x plus xi plus 9 plus 1. Remember, I squared is -1, so negative that would be a plus 1. Combining like terms, we will get I squared minus 6i. The xi's go out, plus 10. Now I still need to take that times x plus 4. I would get x cubed. I would have 4x squared and -6x squared, so -2x squared. I would have, now I'm going for x terms, so I'll have 4 times -6x and 10 times x, so -24 positive 10, -14x, and my last terms would give me plus 40. So this is my polynomial p of x that they ask me to find.